A very warm welcome, everyone, to the Maritime Education Podcast. My name's Barry Sadler, and today I'd like to talk to you a little bit about the impacts of heavy weather on various parts of a ship's operation. Those of you that are here for the first time, a warm welcome to the Maritime Education Podcast. And to those of you returning, it's great to see you back. So, let's talk about the weather just for a little while before we get on to the impacts that this weather can have on the average ship owner. This weekend, that being the weekend of the 3rd and 4th, really, of October 2025, we've seen our first named storm of the season come through, Storm Amy. Now, Storm Amy was a fairly intense storm that created amber warnings across the United Kingdom. Warnings in the UK are based upon the likelihood of things happening and the impact of the storm. So they increase from yellow, amber through to red based upon the risk or the likelihood of it happening and the severity of the storm itself. Now, Storm Amy, the first named storm of the 25-26 season, created 2 amber warnings, one in Northern Ireland and one in Scotland, as it passed across the United Kingdom. At its height, Storm Amy saw gusts of around 83 knots in Tiree in Scotland. Down here on the south coast, I was watching the weather come through yesterday, and we were seeing gusts in excess of 50 knots in the exposed areas of the south coast and at Southampton's pilot station. Amy was a fairly intense storm, and you may remember earlier on in the year we had the most powerful storm in 10 years, Storm Eowyn, which came in January 2025, again bringing very, very high winds and gusts of around 100 knots to parts of the United Kingdom. Now, before we talk about the effects on ship owners, let's bear in mind that storms of this magnitude that come across the United Kingdom have the potential to disrupt transport. They have the potential to cause infrastructure damage and damage to people's properties. And unfortunately, when storms get as powerful as Amy and Eowyn, they can cause loss of life through various means: falling trees, people being swept away by waves, and other incidents caused by the incredibly high winds that these storms can bring. The frequency of these storms affecting the United Kingdom hasn't particularly increased over the past 10 years. We do still look at an average of around 12 to 15 named storms per year. But what is changing is the intensity of these storms, mainly caused by the increase in the temperature of the Atlantic, combined with a repositioning of the jet stream, causes these storms to deepen in pressure, perhaps quicker than they have historically done so, and that very, very deep pressure fall does create a much higher, what we call pressure gradient of wind. In other words, if you're looking on a weather chart, the isobars surrounding these storms are much, much closer together. Gradient wind is the wind that's literally driven by the difference in pressure. And if there is a massive difference in pressure, then the isobars are very, very close together. And when looking on a synoptic chart at these storms, when those isobars are close, that means very, very high winds. For the isobars to be close, there needs to be a very, very quick and deep fall of the pressure in the centre of the storm. This deep fall in the pressure can be caused by lots of different things. It can be caused by warm, wet air rising very, very fast. It can also be caused by the jet stream. The jet stream, very fast moving ribbon of air, about 5 to 6 kilometres above the Earth's surface. Jet streams, as they move across the Atlantic, help to drive these storms towards the United Kingdom. If the jet stream is particularly low, in other words, if its latitude is low, then it drives the storms across warmer sea temperatures, and those storms pick up the heat from the sea, and this generates into an intense storm by reducing the pressure even quicker. If we add kinks to the jet stream, kinks in the jet stream cause an acceleration of the jet stream, and that acceleration of the jet stream only helps to pull the air out of the centre of the storm, again causing the pressure to drop very, very quickly, giving us the intense storms that we are currently experiencing. Now, the main storm season statistically is between December and February. But I think October and November are significant months when we talk about storms, because it's where the weather is changing. We are coming out of summer, perhaps coming out of a period where we've had reasonably stable air masses, reasonably low winds, higher temperatures, of course, but we're talking about winds today, lower wind speeds, and we've got used to operating in conditions where we haven't seen the extreme gusts that we've just discussed. Where October kicks in is where we suddenly see these named storms starting to appear. They might not come across particularly frequently in October, but when they do come across, it realigns our thinking really as to how we're going to deal with these particular storms as they come across. Now, purpose of this podcast is really to discuss how these storms impact the ship owner. And so let's talk about this from a ship owner's point of view, a shipper's point of view, as to what the effects of these storms are going to have. The earliest effects on a ship owner are, of course, needing to reroute your ship around a storm. So rerouting a ship around a storm will, of course, add distance and cause delays to the ship as it makes its passage towards its intended port. Rerouting is a good thing because although it adds distance, which of course will add fuel to the ship owner's bill, it does keep the ship out of the worst of the weather, which means that wear on machinery, ship damage to cargo are much lower than trying to take the ship through very, very high wind speeds. So rerouting, although initially expensive, over the long term can prove to be much more cost effective to the ship owner. The other benefit about rerouting is that the ship does not get caught by heavy weather, period. Now, as well as protecting, as I said, the ship and the cargo, it also has the effect that insurance premiums can stay at reasonable levels. Ships that seem to constantly find bad weather may have their annual insurance premiums increased by P&I clubs as a response to the sometimes necessary routing of these ships through more than favourable conditions, or less than favourable conditions, I should say. So being able to avoid the weather in the first place by rerouting will not only minimise damage to ship and equipment and cargo, but may also have a long-term effect on P&I insurance costs when it comes to annual renewals. Now, if the ship were to hit heavy weather, then the extra fuel to power through that heavy weather must be taken into account. And this is one of the greatest costs to a ship owner that heavy weather can bring. It's difficult to obviously put a number on the amount of extra fuel that heavy weather will cause. A lot of it depends upon not just the wind speed, but on the waves and swells that are generated by the storm as it comes across. I always find that if a storm comes across the southern part of the UK, the centre of the storm comes across the southern part of the UK, although sometimes the average wind speed may not be higher than your average storm, the waves and the swells around the pilot station at Southampton seem to be a lot more adverse. In other words, even in less intense storms, if the centre of the storm passes up the English Channel, we do see increases in swell waves in particular. So it's very, very difficult to pinpoint down an actual percentage as to how much extra fuel would be burnt by a ship that is trying to get through heavy weather. But if we look at an ultra-large container vessel, and we look at that container vessel having to power through force 8 to 9, that will normally increase fuel consumption by around 20%. If that same container ship was approaching a storm like Amy or Eowyn that we've just been talking about, and the wind was on the head, then fuel costs can increase, or fuel consumption can increase by up to 40%. Let's put some numbers to that, shall we? Using the latest average price per tonne of low sulphur fuel. So this is averaged out globally, really. We're currently at around $563 per tonne of fuel. And that's very low sulphur fuel, not ultra low sulphur fuel at 0.1%, very low sulphur fuel at 5%. And as I say, important to say that this is averaged globally and sourced from Ship and Bunker. So let's look at what an ultra-large container ship will burn per day. So to do between 17 and 19 knots, which is a good speed for a ship owner, once you go over 20 knots on an ultra-large container ship, your fuel costs skyrocket. So most passages are planned around 17 to 19 knots passage speed. At that speed, an ultra-large container vessel is doing about 430 miles per day, burning around 180 tonnes of fuel per day, which is a cost to the ship owner of around $101,000. Now, if we're hitting a gale force wind head on, then if that were to increase by 20%, the daily consumption would be 216 tonnes, and that brings the cost up to $121,000, nearly $122,000 per day. Heading into storms, the ferocity of Amy and Eowyn, increasing up 40%, gives you a daily consumption of 252 tonnes per day, or $142,000. So in other words, if you go from favourable conditions into a storm like Eowyn or Amy and having that wind on the head, you're looking at a ship owner of burning just over $40,000 more fuel per day. Now, in good conditions, that 17 or 19 knots is going to get you 430 miles per day. But even burning the extra 40% of fuel, particularly in very, very intense storms, you're not going to be able to make 17 to 19 knots. So your 430 tonnes per day is going to, 430 miles per day is going to reduce. And therefore, not only are you burning extra fuel per day, but you're having to burn it for longer because the ship's speed will not be as high in such heavy weather. Extra fuel, lower speed means that you're going to have those higher costs for a longer period of time. A ship may need to take refuge from a storm. So if the storm is so severe that the ship feels as if it needs to put into a port of refuge to take shelter from the storm, then again this is going to add time to the passage, distance to the passage, increase in fuel costs, and an increase in delay costs as the ship needs to go into port, and basically delays or off-hire clauses that may kick in when these ships do reroute can be anything between $10,000 and $50,000 per day. Now, declaring a port of refuge for reasons of safety will minimise the voyage delay costs to the ship owner, but nonetheless, they're not going to be able to avoid all the costs that come with seeking a port of refuge. Even when the ship does make its eventual destination port, where heavy weather has created problems in the port itself, they may get there to find that the port is congested, the anchorages are congested. That means that there may not be space for the vessel to anchor, so the vessel will have to drift off the port. Drifting off the port means having the main engine ready permanently for immediate use, and therefore, once again, you're burning extra fuel. Congestion in the port may mean there's a delay to the ship berthing, so not only are you using extra fuel to maintain station because of the busy anchorage, you are then having a further delay waiting for all the ships that may have come ahead of you and may be berthed before you to make their port calls. Pilot stations can be closed, and this is something that obviously I have a lot of experience on over the last 25 years. Pilot stations are closed for various reasons in heavy weather. The main reason, of course, being that the swell and wind waves are so large that it isn't safe to take a pilot launch alongside a ship and board a pilot on the pilot ladder. Now, I disembarked the ship in the early hours of the morning on Friday, which was just as Storm Amy was kicking in. And even in that relatively early stages of the storm, we did have a very, very short, sharp, choppy swell from the south. And although we turned the ship practically onto an easterly heading with a portside pilot ladder to disembark, as we were disembarking, the wind and swell waves had caused the ship to roll very slightly, and this was causing the launch to go up and down. We had to be very, very careful timing our stepping off from the ladder to time ourselves as to when the ship rolled towards the pilot launch and the pilot launch raised up the ladder and we stepped down at the optimum time. Now, that's wind speeds when we were out there were barely 30 knots. And with gusts of over 50, you can imagine that the swells would come up very, very quickly, and boarding and disembarking vessels at the pilot station would be untenable. Therefore, with the pilot station closed, once again, delays to the ship owner and an increase in the costs. Tug availability is another factor that needs to be taken into account when a ship arrives in port. Most ports will have plenty of tugs available for ships on regular days as they come and go, but periods of heavy weather, particularly sustained periods of heavy weather, may cause problems with tug cruise hours and availability of tugs. This isn't just because ships are taking more tugs to be able to berth safely, it's because those ships that are alongside in the port may need one or perhaps even two tugs in attendance permanently pushing up on the side of the ship to hold the ship alongside, because the winds are so strong that even though the ship has put out extra mooring lines, those mooring lines are still not enough to keep the ship safely alongside. So tugs can be engaged for hours to push ships up against heavy wind. Indeed, a ship in Southampton booked tugs for 27 hours over the period of Storm Amy to push up. That means that you've got tug crews there that are permanently on for those 27 hours. Obviously not the same crew. The tugs will exchange in order that the crew can be rested, but nonetheless it is drawing resources away from the port and therefore reducing tug availability, again incurring further delays to the ship owner. Berthing parameters may be breached by high wind speeds. So risk assessments are conducted by port authorities on the various berths that they have available for ships, and those risk assessments may include wind limits per ship that if they are broken, then the operation cannot go ahead. Obviously, those wind limits are very, very dependent upon the direction of the wind and the direction of the berth, the availability of tugs. However, if we get high wind speeds like Amy and Aowen brought, those berthing parameters will be breached fairly quickly, and therefore the risk assessment will say that the ship cannot use the berth. The berth itself may not be ready for the ship, even if the ship can berth. Now, the main reason for this could be that the high wind speeds are preventing the port from actually working cargo. So where you've got very, very high container cranes, for instance, you don't want to be trying to swing those containers onto the ship in very, very high winds. It's dangerous. The containers will be moving around in the wind, and trying to drop the container safely between the sail guides in order to get the container stored on the ship can be a real challenge, particularly if those winds are gusting directly athwart ships or gusting directly longitudinally, therefore pushing the container fore and aft or to port and starboard makes it very, very difficult for a crane driver to nail that container into the guide. So it may be that even if the ship is able to berth, that the cargo operation itself may not be able to go ahead because of those high wind speeds. All of those factors will be against the ship owner when their ships experience heavy weather, be it experiencing heavy weather at sea or be it experiencing heavy weather alongside, causing delays in anchorages, damage to the ship, extra fuel that's being burnt. But of course, despite the fact that we're talking about a ship owner perhaps being disadvantaged by heavy weather from a financial point of view, let's focus on one of the primary effects of heavy weather, and that is the safety of life at sea. Heavy weather does cause ships to move around, and although seafarers are experienced in heavy weather and able to perhaps move around the ship more safely than most while the ship is moving, we must still make sure that the crew remain safe and that ships are not unnecessarily put through heavy weather just to be able to make a port with the sacrifice of either injury to crew members, loss of crew members, or, as has happened even fairly recently, losses of ships in heavy weather with loss of crew members on board. Heavy weather does have massive financial impacts, but if it's not managed properly on board the ship, can also be a real danger to the ship's crew. It can be a real danger to other people as well. Pilots trying to board and disembark ships in poor conditions. Tugmasters having to put lots of weight on their lines, move their tugs around the ship perhaps more quickly than they would do normally to be able to deal with the pilot's orders in reaction to some of the gusts that come and go. Key workers working on the quay in heavy winds need to be extra cautious of flying debris on the quay and extra cautious of things like ship's lines, which of course in very heavy weather may part due to the weight that comes on them. Ship's crews, stevedores, pilots, tugmasters, anybody really that's working in and around the ship that's being affected by heavy weather needs to be acutely aware of the higher risk that is generated when that ship is operating in such poor conditions. Although the costs to the ship owner of heavy weather are significant, and a ship owner whose ships are constantly sailing in heavy weather is really going to start to feel the pinch when it comes to financial bottom lines, ultimately it's safety that must be considered first when we decide whether or not to operate a ship in heavy weather, take a ship through heavy weather, or indeed have a ship go anywhere near storms such as Amy and Eowyn. Hopefully you found some of the facts and figures and considerations in this podcast interesting as to how heavy weather can affect the ship owner, and ultimately next time you see a named storm coming across the UK, do spare a thought for those people who are engaged in shipping, those that are working the ships alongside, those that are working on the ships, and ultimately those whose lives are going to be made just a little bit riskier by the presence of a storm coming across. Do heed the warnings from the UK Met Office. In 2015, when these storms started to be named, they were named for a reason, and naming a storm brings people's attention to it. It makes people aware of the potential impact of a storm. They've been doing it for years with hurricanes around the world. So to name storms, particularly in the UK, where we have a lot of them coming through on the jet stream, was a natural progression to highlight the impact of these storms, not just to professionals that were used to dealing with it, but to the general public as a whole. Thank you very much for listening to this podcast, everyone. I look forward to welcoming you back to the Maritime Education Podcast in the near future. In the meantime, guys, do have a great day.